I got asked recently for some help in splitting down the 12S pack into two 6S's. Some helicopters are ideal to take the stick pack, like the TDR just goes down the gullet, or the Logo 600. Other ones like the Casimir 5.5 are better off with separate packs. Now a stick pack is basically just two 6S packs stuck together in line basically. They've got a shrink wrap around the whole lot, and generally they've got some sort of support, glass fibre or card, something like that, front and back, just to give them a little bit of rigidity and aid handling. The positive and the negative of the two terminals are joined together, and then the furthest negative or positive is joined up by one lead, which is probably this negative lead here. You can actually feel it running all the way down here. So this is where the negative comes from, down here, and the positive will come from this near cell here, and then the positive and the negative of the bottom and the top one will be joined internally. This has got Thunder Power balance leads. There's two main systems, as you'll probably be aware. There's a system used by XT and Align and JX, and they're 0.15 of a millimeter apart. So these are the Thunder Power and Outrage style of plugs, originally put forward by Thunder Power. They're not only a little bit finer plugs, they're only 0.1 of a millimeter apart, but they've also got this weird configuration, the reason for which is lost no doubt in the seeds of time, where you have, for 6S, you have a small 4-pin plug which takes the first 3 cells, and then you've got a duplicate wire which is basically exactly the same. You've got a common wire between the 4 and the 6, which will be this black wire here. So they're basically joined together, they're the same. And then you have 3 more wires for the 4S, 5S and 6S pack. So I'll have to decide what to do with these balancers. In a 12S pack, there's basically, there's no way you can do it with one plug on the Thunder Power system. So a 4-pin and a 6-pin plug will come off each LiPo cell. If you've got the XT variety or the JH variety, you can actually use a 7-pin plug, which is one for the ground and then one for the positive on each of the 6 cells. This is a V Plus pack. I've never tried one before, made in Korea. I've heard good things about them. 5200 milliamp hours, and that size-wise is common to most of my 4400 packs, so they're pretty compact, but it's pretty weighty, and that goes with the high capacity. First thing we've got to do is get the shrink wrap off the outside, and basically I'm going to try and conserve the shrink wrap, because if you don't have this shrink wrap available, and it's a bit hard to find, you can actually reuse it by using some PVC or some duct tape. So we're going to slice with a pair of scissors. We're going to try and use the blunt end so we don't dig the sharp end into the pack, obviously, which would wreck one of the cells. And we're going to go down, not the sides where it's easy to puncture the cell envelope, but down the middle on the top, and that should mean that there's a bit of protection there between the scissors and the cells. We're not going to use this side because the label there's quite handy. So I'm just going to gingerly start to work at one end. We have a plastic strip at this end here, so we don't need to worry about the cell safety here. We can get started, and what we'll do is down this envelope like that. And once I've got that started, I'm going to change to the rounded bit of the scissors. A bit hard to get going. What I'm going to do actually, I'm going to use the sharp point, but I'm going to be very careful, and I'm actually levering up away from the cells and just slicing it down like that. And we'll just have a check inside. We've got a good plastic strip in there, so we're not going to cause any damage and puncture the LiPo envelopes, but even so I'm going to be cautious and just fillet it all the way down and snip at the end. Now we can just zoom out. Now we can just split this envelope off, this heat shrink off, and we'll save that because we might reuse that again in future. And here we can see the construction of the pack. Here's our 1, 2, 3, 4, 5, 6 cells to each pack, front to back, and we've got this nice firm, looks like mylar plastic strip anyway, give it a bit of rigidity and also protects the cell. So the next thing to do basically is to get off these incidental bits of sticky tape, which if you're frugal you can also want to preserve, and that'll enable us to take the plastic strip off. It's not a self-adhesive one, some of them stick on there, so this will be easy to take off once we've got these bits of tape removed. Right, we've dissected the pack a little bit more now. We've got a positive lead coming out the left hand pack, that's positive, that's all good. We've got a negative lead, and these are all heat shrinked both ends, so we can tell these are the power pack leads. This comes out the negative end of the bottom pack, and this is a little bit sneaky. We've got a black wire here that is connected to the positive of this pack and the negative of this pack. So basically what we can do is, this is good that we've got this length of wire, we can actually cut this one in half, just about the junction between the two cells. The black colour there will be fine for the negative of this pack, but this one we've got to be real careful with. This is going to be our positive lead on this right hand pack here, so I'll have to put some heat shrink or other identifier down, but this is very neat and makes it easy because instead of having two solder tabs, aluminium tabs that come out of each pack that are soldered together, they're actually joined together with a wire that's ready soldered, so that's great. We don't need to do any heavy power pack soldering. And this is actually very easy because the balance leads for one set, for the right hand one, are down there. They're a little bit on the long side, we'll talk about that later, and then the balance cells for the left hand lead are on this pack here on the left, come out the end there. They can be left exactly as they are now. So first thing I'm going to do, I'm going to chomp this in half, and then I'm going to put some shrink down here to identify that that's our that's going to be our positive lead on the right hand pack. So what I'll do first is I'll cut it roughly in two like that, which is not too bad, and then I'll just clean up these ends with the pooch nippers and see what a lovely clean job that gives. Okay, next thing to do is to identify this as the positive of our right hand pack. So I'll ID that by sticking a bit of red heat shrink down there, and then we'll just put a bit of PVC insulation tape over the ends of here while we dismember the packs a bit further. It's best to keep these covered up. It's not too bad because we've got one of our ends covered up on both the right and the left hand pack. Never ever have bare metal exposed on both of the packs at the same time, because it's sod's law basically that you're going to end up sparking them out, which gives you a hell of a jump even if it doesn't actually cause any harm. There we go, nice and safe. A bit of red insulating tape on our new red lead and a bit of black on our existing negative lead down there. Okay, next thing we've got to do is get this divide this plastic film. Now the ends are quite nicely moulded. In fact, we've got some self-adhesive mylar film bent over the ends, and I'm going to keep that like that and not break these down because there's no need. All I've got to do, and this is simple because there's no self-adhesive on here, I can just take my scissors, round point down, and just cut our way through. Now, being a surgeon and used to sharp instruments, I'm going to actually use the pointy bits here and be careful, but obviously you do not want to puncture one of those envelopes, otherwise at worst you're going to wreck the pack. At best you're going to wreck the pack, and at worst you're going to get a shoot of flame coming out. And I'll just do the same on the other side. Try and do the right thing on this side and use the nice atraumatic rounded ones, which are a bit more trouble than it's worth, so I don't think we're taking a big risk to slice down there like that. And then that's our packs now, 12S stick into two 6S. There's actually good reasons for doing this. International Air Travel Association regulations limit you to 160 watt-amp hours for a pack. Now this one together, this is 44 nominal volts with 5.2 amperes or vampires. Anyway, 44 volts, 5 amp hours, 5 times 40. These are going to be 200 and this 12S pack is going to be 200 watt-amp hours. That's over the upper limit of what you can take, and you can't take these as checked-in baggage on a commercial plane, on a passenger jet. You can send them on cargo planes, but if you've got passengers, you can't put these in the hold. You can't put these in as checked-in baggage. You've got to take them as cabin baggage, or stuff that in your hold all. And you're limited to 160 watt-amp hours. Now these are, as I say, these are split up together. These would be 5 by 22, which is 110. These are permissible. You're allowed to take 3 110 watt-amp hours on the plane with you. If they were a bit smaller, if they were say 4.2 watt hours, then that would be 88, about 90 watt-amp hours. There's no restriction on the number of cells you can take below 100. But these are 110, so you're only allowed to actually take 3 of these, although not many of the security people seem to know or understand these regulations just yet. Now we'll leave this one for now. This is our first stick pack here. So this is really all ready to go almost. You've got your balance leads all fixed up and ready to go. All we've got to do with this basically is move it out one end like that and secure this end down here. So we'll have a look around and see what we've got that we can use for that. So here's our 6S pack. It's got this nice thin mylar reinforcing strip around the end. On the sides, the end's a bit exposed, so it'd be nice to cover that up. I've taken a 2-litre orange bottle, which is nice soft polythene, and cut a strip out of that, just narrower than the battery, and we can either just get a strip of that and put it round the end like that, or in actual fact, as luck would have it, you can actually wrap the whole polythene around the whole Lipo pack, which is what I think I'll do, and you even get a bit of an advert there as well. So I'm just going to put some tape on there like that to fasten it together, and then we've got good protection either end. So I've just trimmed that so it makes a nice butt joint down there, so there aren't any funny steps in your pack. We'll tape that up. Then I've just fixed a couple of glass reinforced tape strips around the side, and quite honestly, if you don't want to, you don't need to do anything more than that. That would be perfectly serviceable and be a nice bright colour down there. If you want, you can get some heat shrink tubing like that. You need the length of the two sides. That's 55, and that's 50. So that's 105 plus 10%. So that's 105. This is a little bit big. This is 120. You probably need about 10% shrinkage factor. 110 would be ideal for that, but 120 will shrink down quite nicely. So if you want, you can pop that in there. Leave a little bit of an overlap on the end. Make sure there's no sharp edges where your wires are going to chaff against, and if you're worried about it, put a bit of insulation tape down there, and I think we'll heat shrink this one. You'd use a heat gun for this, but I don't have one, so some careful blow torching should do the job. It's quite hard with a blowtorch to get it to shrink down evenly, I find. And there you go, shrink wrapped. A little bit too easy to burn holes using the blowtorch, but there we go. And last but not least, you want to label these so that you know what's in there. There we go. The brand, the capacity, so you know what to charge rate, and most important of all, how many volts it is, so you don't overcharge 6S. We charge it to 25.2 or 4.2 volts per cell. Okay, next up we'll put some power connectors on here and then we're done with this pack. Now this is our number 2 pack, so we've got a few choices here. These balance leads are incredibly long. The choices are basically to cut them down and then solder wire to wire, which is 7 different wires, and then you'd have to shrink one each individually. I suppose that's ideal, but I think that's too much work and the chances of error or problems in the future are too great. I haven't been able to find these Thunder Power connectors sold individually, so they must be somewhere, but I haven't been able to see them. You can buy the XT connectors loose, which you could put on there, so we could convert them to XT. Or the easiest thing to do, quite frankly, is to just make a nice loop down there and then heat shrink them over. In an ideal world, you have short balance wires, because when you're talking about 0.01 of a volt, even a few centimeters can actually affect that. But it's more important to have good contacts, I think, than worry too much about the length. At least they're all the same, so they should balance. And then the other thing we've got to decide is how long to make these wires here. This is our positive, this is our negative. Depending on how they're going to be hooked up, you're going to have to make some sort of wiring harness. So I think I'll just make these the length of a contemporary pack. So I'm just going to cut this one down here, the same length as the other, and then at least they're evenly matched. Comme ça. And a bit of insulation, as before, on the end to avoid tears until we're ready to solder up our connectors. Okay, so same deal as last time. Just going to put some strip cut from a milk or a juice container, and then just wrap it round, and then we'll pop some heat shrink on. There's our number 2 Daily Juice Company pack. It's rather a nice logo, that is. I think if it was probably my pack, I'd leave that just as it is. Anyway, we'll wrap up our balance lead there now and put some shrink wrap down and try and make this out as flat as I can do. And there's pack number 2. There's pack number 2. Heat shrinking a little bit better that time. Orange container each end, nice and secure. As mentioned before, just have a look and see if there's any sharp edges against the wires, and if there is, then just cut out a little bit of the insulation so it's not chaffing on the wires and folded over. So I'm going to just cut out a little recess there, like that, and then you just be careful with the wires. Okay, so there's our 2 6S packs out of 12. Lastly is a final check as to the quality of the cell and the balance connectors. We've hooked up these Thunder Power connectors to this Pulsar Equal, and then we'll zoom in on the screen and we'll see the 6 cells there. That's our volts per cell, so it varies between 3.8 and 3.82. So that means there's a variation of 0.02, which is pretty good to start. And you can see they're at 3.8, which is the correct storage voltage for a Lipo. So looks pretty good.